Hello, dear students. Today we're going to complete chapter 4. As you know, in previous lesson we have finished section 1 of chapter 4, and today we will start to study chapter 4, section 2, by determining pH and titration. Well, today we're going to study the concept of pH and the titration process. The titration process is totally new for us for now, and we don't have any idea about the titration. But inshallah, we will have a very deep information about it by the end of this lecture. Before starting to study of titration, we have to study something else. For example, the indicator. Because of the indicator is a chemical reagent that is mandatory to be used during the titration process. Excuse me. Well, we can find the pH value by two different ways. The first way is the indicator, and then by the pH meter. Well, but indicating pH using indicators is approximation method. It's the approximate value. So we can get the value of pH just using the indicator. It's a fast way, just like a kit when it's used by medical laboratories to doing some fast tests. But the result is approximate result. It's not the precise and accurate result. So the approximate value of pH can be obtained by what? By the indicators. By the indicators. Using the indicators, we can get the approximate value of what? pH. So now we can see that there's a relationship between pH and indicators. But we don't know what kind of relationship. Well, acid-base indicators are compounds whose colors are sensitive to pH. It means the color can be changed with changing the pH of the medium. So that's the relationship between the indicators and the pH. So the color of the indicator compounds, the color of the indicators can be changed. But when we have pH change it. So if we change the pH value, what will happen to the indicator? The color going to be changed. So that's the property of the indicators. The color is sensitive to pH. The color is sensitive to pH. Of what kind of compound? Indicators. Acid-base indicator. Well, let's study how the color of indicator changes with changing the pH of the medium. Actually, this is very important and it's very useful. Look, the indicators generally are weak electrolyte, and the formula of indicator is HIN. The indicators, acid-base indicators, are generally what? Weak electrolyte. Okay. For example, we have HIN in here. Okay. It will dissociate to producing H plus and IN. Dissociate or dissociate is the same. HIN can ionize to producing H plus and IN negative. Well, if we put indicator in the acidic medium, well, in the acidic medium, teacher, what kind of ions we have in the acidic medium? In the acidic medium, there's a lot of H3 plus ions. H3 plus, it means H. Okay? In the medium, that's acid, there is too much H plus ions. So the concentration of H plus is very high. So when we put indicator into the acidic medium, immediately, what will happen? Look, immediately, it will combine to IN. It will combine to IN. IN plus H to forming HIN. Oh, so now in the acidic medium, that means mostly the indicator form is HIN. Why? Because of in the acidic medium there is too much H plus. This H plus will combine to the IN negative of the indicator to forming what? To forming HIN. Now, can you explain the formula for the indicator in the acidic medium? HIN. HIN or IN? No, teacher. There is a very trace amount of IN ions. Why? Because of IN ions mostly are combined to H plus of the acid that came from the medium to producing HIN. So here the formula of the indicator in the acidic medium, which is red color, Well, let's change the medium to the base, to the alkaline medium, and to see which formula of the indicator will increase, IN or HIN. Okay, we have this reaction also again. In the base, in the alkaline medium, we have OH ion by a large concentration. So this OH ion will combine to the H plus of the indicator from the product. So all the amount of H plus will react with OH to forming H2O. Now what will happen to that H plus? So the product of that reaction will be in lack of H plus ion. So what will happen to that compound? This compound will ionize or will dissociate more if it's ionic, and if it is molecular compound, will ionize to losing amount of H plus by reaction with OH. So, okay, HN, this guy feels that there is lack of H plus because of he lost all of his H plus in the product by reacting with OH. So he will dissociate, he will ionize more to producing H plus again. So it will shift the equilibrium, fluctuates the equilibrium. So the forward reaction will be favored, and mostly the indicator formula will be IN. In the base medium will be IN. Why? Because of all the H plus are reacted with OH to producing H2O, and this compound begins to more ionization process to producing or to replacing that H plus that lost by the reaction with the OH. So in the result, what do we have? IN negative in basic medium, which is blue color. So what formula of the indicator do we get in the base medium? In the base medium, IN. What about the acidic medium? HIN, red color, blue color. From now on, memorize that. The color of the pH acid-base indicator in the acidic medium is red, and in the base medium is blue, but in neutral it is green. So that's about the color change of the indicator by changing the medium pH from the acid to base or from the base to acid. The ionization of HIN indicator in acidic medium is, in acidic medium, the ionization increases or decreases. Because of, this is the formula of the indicator in the acidic medium. It means there is less ionization, decreased the ionization. But in the base medium, the ionization increased to replacing what? To replacing the lost amount of H plus. The ionization of HI indicator in the base medium, well, in here we mentioned that. So for the acidic medium, this is the right answer. And here, increase it is the right answer. The HIN indicator in acidic medium presents us, well, the indicator formula in the acidic medium presents as what? Acidic or base, teacher? Well, here we have acidic medium. Okay, in acidic medium we know that it's HIN. But what will happen if we change the medium to the base or to alkaline medium? Okay, that's also is very easy. It will becomes IN negative. I think we have that kind of question in here. The HIN indicator in basic medium presents as what? Well, it means formula. HIN, no, it is acidic medium. IN positive, no. This is totally wrong. INOH? No, I don't know where it came. IN negative, yeah, because of he lost its H plus by reacting with OH to forming the water molecule. That's why, because of we have many different acidic compounds and reagents, in contrast also we have many different reagents that are alkaline. So scientists are thought to preparing a general indicator called universal indicator. Well, there are a lot of indicators in the laboratory, so they prepared a mixture of the indicator and then sinking a pH paper into that indicator. And after drying that paper, if we put this paper into any medium, we can check the pH precisely or approximately. Did you remember? This is indicator way. So the pH is approximate. It is not precise. It's not accurate. So when we put a pH paper into the different reagents, it can form a rainbow color. Okay? So just by comparing the color to the standard color, we can decide that approximate pH of that solution is that. For example, in here is 40, 30, 12 until the dark red color, which is 0, related to the very strong acids, which are diprotic acids. Now let's talk about the second way to identifying pH of the mediums. pH meter determines pH of the solutions very accurately, very precisely. Okay? So that's the difference between pH and indicator. For the indicator way, we have approximate value. For the pH, we have a precise and accurate value. Well, before starting to study the titration, we should have the idea about the type of the salts. We should recognize, we should know how many types of the acids exist. Okay? Of salts exist. It means there are different classes of the salts. So we should know what are the classes of the salts. Well, if you don't memorize it, the list of strong acid and strong bases, so you cannot understand from here. That's why I prefer to you, before checking this video, stop this video in here, and then memorize the list of the acid, strong and weak, then watch this video again. But if you memorize it already, this is better for you, and good job. Well, there are 4 types of salts. Look, first type, salt of strong base and strong acid. It means we have strong base and strong acid are reacted together, called neutral salt. The pH is 7, such as Na or NaCl. Na came from NaOH, Cl from HCl. They are strong acid and strong bases. For CaBr, CaOH by 2 and HBr is the same. Well, salt of both strongs is a neutral. Salt pH is equal to 7. Salt of weak base, strong. Salt of weak base and weak acid. Where the pH is not identified for that kind of salt, we should find out the value of Ka and Kb. We will learn in chapter 7. But now we don't have a specified name for that kind of salt. If both are weak, well, we don't know the pH value. Third, weak base with strong acid. Because of the acid is strong, the base is weak, so it will win from this fighting. So the taste will be related to the acid. The property will relate to the acidity. That's why we call that kind of salt acidic salt or sour salt. The pH is smaller than 7, such as NH4Cl. It's from NH4OH and it's from HCl. HCl is strong acid, NH4Cl. NH4OH is a weak base. Salt of strong base and weak acid, it's exactly vice versa to the point number 3. Basic salt, called basic salt, alkaline salt pH is greater than 7, such as KCN. K from KOH, CN from HCN, which is weak acid, and it's strong base. Just for reminding you that salts are ionic compound, consists of cation and anion. The source of the anion is the acid. Let's check all 4 types of salt with the different formula of the salts. Look, here we have CH3COOH, and here we have NaOH. It's strong base, it's strong acid, so pH bigger than 7, it's basic salt or alkaline salt. Very easy. NaCl, Na came from NaOH, Cl came from HCl. Both are strong, it's neutral salt. pH is equal to 7. pH is equal to what? 7. And in here, look at here. CH3COO, NH4, both are weak. So what will happen to the pH? We don't know, teacher. So that will be our problem for the titration process. NH4Br, it came from NH4OH and it came from HBr. Weak base with strong acid. Weak base with strong acid. So they will be acidic salt. pH is smaller than 7. Very good. Now, which of the following salts has the highest pH value? NaCl is a neutral salt. pH is equal to 7. Good. NH4Cl, it's basic salt. It's acidic salt, excuse me. It's acidic salt, so pH is smaller than 7. NaF is an alkaline salt, basic salt. pH is greater than 7. Its pH is equal to 7. So which of the following salts has the maximum pH value? Of course, the answer of C, which is alkaline salt. Now let's start to studying the titration process. What is the titration process? As I told you, it's totally new, but it's totally easy. Let's do it. What is the titration? Before explaining the titration, I prefer to show you the apparatus of the titration process. First of all, I'd like to explain the apparatus of the titration because of it helps you to understanding all of the other theoretical things. Well, this is the apparatus of the titration process. It's called burette. Well, the name of burette is not mandatory for you. You are not obligated to memorizing burette. And it's conical flask or these flasks, well, they are not important for us. But the importance is that when we're going to work in the laboratory and preparing some reagents, for example, we're going to need 20 milliliters of the hydrochloric acid, but we don't have a glassware by 20 milliliters, so we should prepare a liter of the hydrochloric acid, and we only need 20 milliliters. So what will happen to the remaining amount? Wasting? No, because of the resources are very expensive nowadays, especially the lab resources are very expensive. So we should spend more money. That's why we have to keep the remaining amount of the HCl. But by passing a period of time, what will happen to that reagent? Because of mostly the compounds in a laboratory are sensitive to light, or they are volatile, or they are reacting to the wall of the container, wherever, or the impurity in the air during the preparation process. That's why by passing a time, the concentration will be changed. So if we're going to use again the remaining amount for after 1 month, what will happen to the concentration? The concentration is changed, so we don't know the right concentration. That's why we should to calculate the right concentration again. We should do what? Calculating the concentration again. Okay? How we can calculate the concentration again? We have to use the titration process. For the titration process, this is our sample. Okay? For example, we have solution of HNO3. We just store the HNO3. After a period of time, the concentration changes. So we have a plan to calculating the concentration again. How we can do that? Look, take a known amount of HNO3. It means volume is known, but the concentration is unknown. Okay, and here we have known volume with unknown concentration. Good. But what will happen to that tube? We should fill that tube with the standard solution. Oh, now we have a new term, which is standard solution. What is standard solution? Look, here we're going to put a solution with known concentration. It means concentration is known precisely, accurately, but the volume is unknown. Volume is unknown. Now we have two known with two unknown. So we have a plan to find, to calculating, to getting the result of the concentration. But if we want to calculate the unknown concentration, we have to find out the volume of the unknown. So we're going to open this valve, and it will start to drop in the acid. Here we have acid, here we have the base. Okay, so just adding drop by drop and shaking with adding continuously. So we have to shake this flask until we are adding continuously the base compound. So, but we cannot see the medium, the pH of the medium that changes or not. But just expect that. Now, still now, I didn't mention it, indicator. So, what will your thinking about this process? And here we have base compound, and here we have acidic compound. So if we add base continuously, the pH will be raising continuously. Okay? Until reach the point, at that point we have equal strength of OH with H3O. At that point, we should close the valve. Now we can see that there is an equilibrium between the strengths of the OH and H3O. They are chemically equivalent. These two chemicals are chemically equivalent. But how we can identify this point? How we can identify this point? Well, we have a type of compound called indicator. Did you remember the indicator? So before starting to the titration process, we should add the indicators. The indicator. Well, when the pH changes by a large value, immediately the color of the indicator in here, it's acidic medium, red color. So adding continuously, the medium becomes too alkaline. So when this point reaches, adding an excess drop, adding excess one drop, so the medium becomes too alkaline. Immediately the color of the indicator turns to blue. When we see the blue color, immediately close the valve and say, okay, this is endpoint. At the endpoint now, we can read the volume of the standard solution. So now the volume is known. Now concentration is known, volume is known, volume is known, concentration is unknown. Just using this equation, we can calculate the concentration of unknown, just like that. OH times 2 volume times 2 cons is equal to H3O times 2 volume times 2 cons. So we know OH, we know H3O, volume and concentration is already known, the volume is known, so the only missing information is the concentration. We can find out the concentration. Now, what is the goal of the titration process? Calculating the unknown concentration. We can calculate the unknown concentration with this process. This is titration process. Now, let's explain the titration. And what's the standard? Titration is the controlled addition of measured of amount of a solution of known concentrated required to completely reacting with unknown concentration. So we will get the result of unknown concentration using dash process, titration process. What's the importance of the titration? Providing a sensitive mean to determining the chemical equivalence amount of the acid and the base. Equivalence. Did you remember? Equal strength between the acid and the base. Standard solution, did you remember? This is standard solution. It means the concentration or the amount of solute is known precisely. Is a solution that contains the precise known concentration of the solute. During the titration process, standard solution must be used. Well, for example, you're going to buy a kilo of the orange. So the owner of the shop will use a balance. Well, I'm talking about the old version of the balance. They are using a standard weight, which is a piece of iron on a side, and then on a side the amount of orange. So when they are equal to each other, it means you just weighted a kilo of orange. So that means because of that standard weight, we are sure that the amount of orange is 1 kilo. But what will happen if we are not sure about the standard weight? Put a piece of iron as it is. Well, without measuring, without reading the value, the number on it, that's 1 kilo or 2. What will happen to your measurement? Of course, will be wrong. So it is the same thing in here. We should use a standard solution, known concentration, to calculating the unknown concentration. Actually, using indicators is not a simple way. We should find out, we should detect, we should specify the pH of the equivalence point between the acid and the base. Then we can decide what kind of indicator must be used or is suitable for that process. Well, we have some chemicals. Let's explain one by one. Actually, because of all the chemicals in the laboratory are solid and they are stored in a bottle, so we don't have any solution. So that solid compound called primary standard solution is a highly purified compound used to check the concentration of known solution, which is called standard solution. So primary standard solution is a solid compound and the concentration is precisely known. It's a solid compound and the concentration is precisely known. But standard solution is a liquid, it is a solution and the concentration is precisely known. So both are, the concentration of both of them, I mean primary standard and standard solution, are known precisely. But what's the difference between them? For primary standard, it's not solution. It's a solid compound. It's solid purified compound. But the standard solution, no. It's a liquid. It's a solution. It means primary standard, after dissolving in the water, it will be standard solution. Primary standard, after dissolving in a solvent, it will be what? Standard solution. Well, primary standard, after dissolving in a solvent, it will be what? Of course, if the amount is known, the solution will be standard solution. Now we have 2 points. I just mentioned it, endpoint. Endpoint, I remember you told me at that point, the color of the indicator changes. Look, is a point in the titration at which the color of the indicator changes. But what is the equivalence point? The equivalence point, actually, when we see the color change of the indicator, it means we just passed the equivalence point. Equivalence point is too hard to be detected. It is too hard to be detected. That's why firstly we should detect the endpoint, then we can approximate the equivalence point. We can say that, okay, according to the endpoint, the equivalence point must be in here, or must be here. So it means we just approximate. We have just the approximation process to detecting the equivalence point. But the endpoint, we are sure due to the change of the indicator. What can be observed about the rate of change of the pH solution near the endpoint? Of course, there will be a rapid change in the pH. Due to that rapid change in the pH, the color of the indicator changes. So how we can detect the endpoint? There are 2 ways to detecting the endpoint. The first one is the indicator. We can see the change in color. But what will happen if we didn't have the indicator? Well, maybe we may have a pH meter. So a pH meter is a device can be used to detecting the endpoint. Because of there's a rapid change in the pH, that's why we can see that change using pH meter or the indicator. So there are 2 ways to detecting the endpoint, by indicator and by pH. At equivalence point, we have OH and H3O in the equivalence amount and strength. Volume of the solutions are equivalent also. The equivalence point or the endpoint, look, okay. The equivalence point or the endpoint can be detected by, look, the equivalence point or the endpoint can be detected by 2 ways. Did you remember? It's too hard to calculating or to detecting equivalence point. Firstly, we should detect the endpoint, then equivalence point will be approximated. Will be estimated, or equivalence point can be detected by what? By indicator and by pH meter. Good. Now, in acid-base titration, the volume of 2 solutions are chemically equivalent. The answer of D. In the titration of NaHCl, a rapid change in the pH value can be observed. Well, can be observed at the equivalence point, at the endpoint, at the equivalence point, teacher. But, oh, we don't have equivalence point. Well, we have another information that has the same meaning of the equivalence point, which is at the equivalence point, H3O with OH is equivalent. So that's the right answer. At that point, a rapid change of the pH can be seen, can be observed. Indicators, of course, are classified according to the range of pH of the equivalence point. Here we have a list of indicators. You have to memorize one by one with their values of pH. Memorize this table as it is. Look, if the acid is strong and the base is strong, so the proper indicator is bromothymol blue is the best one because of the wider range. Even methyl red can be used, but it depends on the pH. According to the pH, well, it's more preference indicator for the strong acid and strong base. It means neutral salt. Strong acid and weak base. Okay, we have methyl orange. The acid is strong. Orange always has sour taste, so the acid is strong. Methyl orange, acidic taste. Okay, the acid is strong, so it's acidic salt. So we should use acidic indicator, which is methyl orange. Okay, orange always has acidic taste. So I can memorize from this point. If we have weak acid with strong base, so we have phenol red and phenolphthalein. The best one is the phenolphthalein. So we have two indicators for both strongs. We have two indicators for strong acid with weak base. We have two indicators for weak acid with strong base. But among them, we have three best ones. Okay. Why aren't there any suitable indicator for weak acid and weak base? Look, we don't have weak acid and weak base. Did you remember the indicators are chosen? The indicator must be chosen according to the value of pH of the equivalence point. So if both are weak, we don't have specified pH value, so how we can choose a proper indicator? That's why, because of the pH of the equivalence point of weak acid and weak base, titration could not be calculated. That's why we don't have a proper indicator. What's the role of the indicator? Of course, the role of the indicator is just changing color at the end point or the equivalence point. On what basis the indicator selected? Of course, the range of pH of the equivalence point. Well, now indicators that undergo transition at pH 7 are used to determining the equivalence point of strong acid and strong base, because of when we neutralize the neutralization process between strong acid and strong base produces a salt that has a pH equal, the pH of the equivalence point is equal to 7. So why we use indicator that changes pH lower than 7 for those titrations between strong acid and weak base? Why? Because of the neutralization process between strong acid and weak base produces a salt which pH of the equivalence point smaller than 7. Look, there's a relationship between them. Why those indicators with changing the color higher than 7, at pH higher than 7, use it for the titration between weak acid and strong base? Well, higher than 7. So in here we will get a salt which has a pH of the equivalence point greater than 7. Transition intervals, I'll leave for you, so memorize this. Now, the neutral solution turns pH paper color into, did you remember? Blue, green, in the medium is the neutral. Did you remember? Green. So we have the green color of the pH paper in the neutral solution. What's the equivalence point of HCl by NaOH? Both are strong. Its neutral salt pH is equal to 7. pH of methyl red is this range. Well, it's easy. It doesn't need to explaining, because of you should memorize the list of the indicators with their pH values. How do you find the equivalence point of the titration? Oh, there was two ways. Indicators and pH meter. Indicators and pH meter. The right answer is C. C is the right answer. What is the suitable indicator for strong acid and strong base? Okay, both are strong. The first class is the bromothymol blue. Bromothymol blue. So, this is right answer. The neutral solution, well, this is this is second time we meet this question. What's the equivalence point of HCl and NH4 OH titration? Oh, it's strong acid and it's weak base, so the pH of the equivalence point must be lower, 7, or below 7. So it's smaller than 7. pH smaller than 7. The right answer is C. Smaller than 7 is the right answer because of the acid is strong. pH of methyl orange. pH of methyl orange. Well, we have seen this question again. Those dyes color that affected by the pH value can be used for. Okay, did you remember about the explanation of the indicator? Indicators are compounds that their color are sensitive to the pH value, so they can be used to making the indicator. There are 3 types of the indicator according to what pH value that detects the color. Dash is the solution that contains a precisely known concentration. Well, it's a solution with precise concentration. It means standard solution. It's standard solution. Now, which of the following titrations has pH of the equivalence point less than 7? Oh, less than 7, it means acid is strong, but base is weak. So it will have pH of the equivalence point below 7, smaller than 7. Strong acid with strong base? No. Strong acid with weak base? Yes. Well, let's continue reading the other options. Weak acid? No. Weak acid? No. Even we don't have any indicator and we don't have the specified pH value for that kind of the titration. So that's all about the pH of the equivalence point and the titration process. Now you are familiar with the titration process. In the titration process, we just make the equilibrium of strength between the acid and the base by continuing adding and then detecting the endpoint. But how we can detect the equivalence point and endpoint? Okay, there are 2 ways, by titration, by pH meter and by the indicator. Well, how we can choose a proper indicator for any titration? First of all, we have to know what kind of chemicals do we have in this titration process. Okay. Chemicals are acid and base. Well, I'm talking about the strength. Well, the acid is strong and the base is strong. Okay, that's better. If the acid is strong and the base is strong, will be bromothymol blue indicator. You see? So identifying the type of salt, it's very important for the titration process. So don't forget about this list. Look, I prefer to you again, please memorize this list one by one. بمشوية كتايبة واني أمرو دينين إن شاء الله لو أنا سيم بندي توار تعودكين كتونتي شكار كني برسيار حسابية كانا تاو كاد بخواتان دسبيرم هر سلامت بمينن وخواتان لقل